Do, 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 do. Hello, 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 beautiful people. So today, right now, I'm going to need you to train your focus. Focus only on this because we will be going over Strong Medicine. Amazing book. Buy this book, read this book. Go over my videos on the topic of this book. This book, as I say here, is one of several books that are necessary for you to get the base level understanding that will enable you to understand the more advanced concepts that I will share with you later in this course. Understanding these concepts and understanding how they apply to you is essential to success in this program, achieving your optimum health, fitness, performance potential. So, without further ado, let us get started. Strong Medicine. Look at this. It's amazing. Got the staff of Asclepius right here. Got a little doctor thing. Dude looks like a badass motherfucker. He's got kettlebell. And it's by Chris Hardy and Marty Gallagher. If you saw the previous video, you know a bit about them. So, this course on this book is going to follow the pattern of the book. I'm basically teaching the book. So I created these slides so that I can teach the book efficiently. This is the first one, basic training, first chapter of the book. So if you're reading the book, which you need to be doing, you should be reading this book. You should have already started reading this book. You recognize basic training. So basic training, let us begin. The central themes of basic training are inflammation and oxidative stress, the gene-environment connection, hormesis, the stress response, and allostasis in the stress cup. These will all be very, very familiar to you. So, inflammation and oxidative stress. So, inflammation, oxidative stress are the underlying causes of most, if not all, chronic disease, and they have a symbiotic relationship. 4 signs of inflammation: redness, heat, swelling, and pain are indicative of inflammation, which, as I say, go along with oxidative stress. So more on inflammation. The inflammatory response directed by the cells. I'm not going to read this because this is just it. Well, I will read this. So the inflammatory response is directed by the cells in our immune system and is absolutely essential to heal from injury and to combat infectious diseases. During an acute injury or infection, redness and heat are produced from increased blood flow to the area. Swelling is the result of fluid protein leaking from the blood vessels into the tissue. Pain results from the stimulation of nerve endings by inflammatory cytokines, these messengers. The process lasts for several days while the battle to clear the invading infection takes place. The damaged cells are cleared out. After the battle, things slowly return to normal. This is the process of acute inflammation. Primary generator of inflammation and resulting oxidative stress in our bodies is the immune system. Basic survey of the immune system is in order. The immune system is incredibly complex and will simplify the immunological concepts without drowning in details. Inflammation is absolutely essential for healing. It causes oxidative stress in the body and is triggered primarily by the immune system. So when we're consuming seed oils, when we're consuming refined sugars, we're consuming things that are causing inflammation, it does it by one of 2 different pathways. One, it either stimulates the immune system to react to it, as we'll go over later, or the second is that it directly produces oxygen-free radicals, which are essentially oxidative stress. Oxygen-free radicals are oxidative stress. Inflammation and oxidative stress are the same. Oxidative stress causes inflammation. Inflammation causes oxidative stress. They're essentially 2 levels of resolution at looking at the same thing. Immunology 101. So the innate immune system stops anyone who looks suspicious, reacts to bacteria and foreign particles, does not attack specific antigens, destroys foreign invaders, is faster than the adaptive immune system, releases inflammatory cytokines, displays bits of destroyed antigens. And the innate immune system guards are the guards of the castle gate. This is the guardian. So the innate immune system basically is the body's first line of defense against anything that gets in that is determined to be foreign. And as we see here, the innate immune system, what it does do is it'll react to the virus, bacteria, or foreign particle. It'll attack it, and then it will create a display of it. It will, it begins the process of programming the body to react to that specific antigen. So the way this works very commonly is vaccines. So you get a vaccine, you inject a bit of foreign material into your own body. Your body then reacts to it with the innate immune system, then goes, does its thing. And then now the body has reacted to it with the innate immune system, and it begins to then trigger the adaptive immune system to develop a pre-programmed response to this thing, should we ever encounter this again. For this reason, the innate immune system is much faster than the adaptive immune system. The adaptive immune system relies on the innate immune system to trigger it, but the adaptive immune system does not rely on the innate immune system once triggered, once created. So, and the innate immune system, as all immune reactions, produces inflammatory cytokines. So now to the adaptive immune system. The adaptive immune system is the part of the immune system that becomes programmed to react. This is comprised of T cells and B cells, and after becoming programmed to attack a specific antigen or something perceived as an antigen, it then creates an army of itself. So these T cells and B cells will then create a lot of them. So let's say it creates one T cell or B cell that reacts to a specific antigen that then clones itself. And now you have an entire army of these adaptive assassins, or T cell, B cells, the adaptive immune system. Let's call them adaptive assassins just for a shorthand. So the adaptive assassin, they have an army of adaptive assassins that then will attack these specific things. So the way this works would, like, here's a great example of how this works in people and why this causes issues. So let's say you are a normal person who's eating a normal standard American diet, or SAD, because the standard American diet is very, very sad. You know that if you're here. So you're eating a standard American diet, and that contains gluten. Well, gluten is very inflammatory to the gut. Most guts cannot process gluten. So now you develop a leaky gut. So not only do you have gluten bits that end up in your bloodstream, but you also have other bits of food that end up in your bloodstream as well. So these little bits of food, these trigger the innate immune system. The innate immune system then starts reacting to these bits of food. Hey, what are these bits of food doing? These bits of food aren't supposed to be in our bloodstream. They aren't. The only reason they're there is because something created a leaky gut scenario. Now that we have the leaky gut and the food in the bloodstream, the innate immune system says, whoa, we're attacking these things. This stuff is bad, gets it out of there. Good job, immune system. Definitely want to attack stuff that shouldn't be there. But here's the issue. Innate immune system now triggers the adaptive immune system to react to that thing again and again and again and again. So whatever food particulates, many of the food particulates, chemicals, and things that end up in our bloodstream from leaky gut, we now become allergic to them. Our immune system now reacts to these things as though they were bacteria, viruses, things that would do us harm. And this is how immune reactions to foods begin to develop. One way that they begin to develop is that a leaky gut will trigger the innate immune system by releasing food particulates into the bloodstream, and the innate immune system programs the adaptive immune system to react to those foods. So now whenever you eat those foods, you end up getting an immune response to those foods, even if you're not having leaky gut. Even after the leaky gut goes away, you'll still have an immune response to those foods because your innate immune system has programmed your adaptive immune system to react to those things. Now that your adaptive immune system has a bunch of these T cells and B cells that are pre-programmed to attack this, anytime you consume that, for the most part, immune response, which, as we know, inflammation creates inflammation and oxidative stress. So, more about the immune system. Immunology 101, T regulatory cells, TREG cells. if you really should be reading this book. So if you're reading this book, you're going to notice that I'm ripping the book off hardcore. I'm hardcore ripping this book off. And that's a good thing, because this book does a great job of explaining these basic concepts that we will elaborate on later. I mean, I'm ripping off like the Lego minifigures, like these Lego minifigures using to represent the immune cells. Totally just taking that from the book. It's a great, literally using the same exact ones they use for the most part, except for the Green Ninja. But yeah, I'm teaching the book. So if you're reading the book and you're like, this is the book, yes, I'm teaching the book right now with a little bit of elaboration, to the point of literally including the hippie anti-war Lego minifigure from the book. This is how they represent it in the book. It's a great book. Everyone should read it. So the anti-war protester is the Treg cell, and the Treg cell is it calms the body down. It prevents the immune system from going out of control. It chills out the adaptive assassins, produces an anti-inflammatory response, and generally prevents the immune system from attacking the body's own tissues. When Treg cells become downregulated, you have too few Treg cells, the adaptive immune system and the innate immune system become hyperactive, and they literally react to your body's own tissues. This is autoimmunity. Autoimmunity is your body attacking its own tissues. We're going to get into later how the Treg cells become downregulated, because that is a major contributor to chronic disease. So that when people end up in a chronic disease state, they end up in a state where their Treg cells, the T regulatory cells, the anti-inflammatory cells, the immune system chilling out cells, they're no longer being produced in great enough quantity to calm down the adaptive immune system, to prevent it from attacking its own tissues. So acute chronic inflammation. So we already know that the immune system triggers inflammation, and that inflammation and oxidative stress are one and the same. So is inflammation bad? Well, we already went over that inflammation is necessary for healing. When you work out, your muscles become inflamed. That's an inflammatory response. It's also a hormetic response. We'll be getting into that. So when you get this acute inflammation as a result of hormetic stressors, infection, minor stuff, even like an injury, like a cut, your body becomes inflamed around there in order to ward off infection, in order to heal the area. This is a good thing. This inflammation is very good. Where this becomes bad is when we have chronic inflammation. Chronic inflammation is the same as acute inflammation, but it is chronic. Instead of dying down after a few hours, days, or etc., it lasts for weeks, months, years, decades. And this constant release of inflammatory cytokines and oxygen-free radical species it puts a lot of stress on the body. It puts a lot of stress in our organ systems, and it creates many issues, because our bodies are not meant to be in a chronically inflamed state. Inflammation is like, I guess like a good example would be like cleaning the oven out. Like you're cleaning the oven out, you turn the oven on cleaning mode, you let the oven heat up, it kind of bakes the stuff off and you clean it out, and it's good. But if you just leave the oven on for days, weeks, and months, you're gonna like break the oven, you're gonna burn down your house. It's a terrible idea. Another fun fact is that 70 to 80% of the immune system is in the gut. So this is another reason why food is so critical to inflammation, oxidative stress, autoimmunity, and these things, because the primary location of our immune system is our gut. So whatever we're putting into our gut is going to be interacting most directly with our immune system, which, as we already said, controls inflammation. So oxidative stress, throw this right here. So oxidative stress in the book is represented as the crazy drunk guy. And the metaphor they use is that you're at a club, and you're at a club partying, and like there's going to be a few crazy drunk guys, but it kind of keeps things interesting. This would be a hormetic stressor, the low level of oxidative stress that keeps our body working properly, keeps our body strong, healthy. If we don't have any stress, our body adapts to low stress, and then we become less capable of handling stress. So a little bit of stress is like a few drunk guys at the club, makes things interesting. But, as it says here, created by the free radical oxygen species comes from pollution, infection, smoking, radiation, seed oils, etc. Seed oils directly import free radical oxygen species into your body, especially if they're rancid. Radiation will cause free radical oxygen species by ionizing the oxygen species, causing a free radical. And smoking, pollution, you're again mainlining free radicals into your body in the form of carbon monoxide, etc. Carbon monoxide is one of the most commonly known free radicals, and that's the one most commonly exposed to when you're smoking. Smokers just mainlining that oxygen free radical species right into your body. I used to smoke too, so like I get it. It's dumb as shit though. Don't fucking do it. I got methods to quit that stuff easy. It's bullshit. Everyone knows it's bullshit though. No one even likes smoking anyway. But yeah, these oxygen free radical species are the same process that actually rusts cars. It's just basic chemistry. If you've ever taken chemistry, you're well aware of redox reactions. But that's what starts to happen to our body. These free radical oxygen species are going around our body and they crash into things. They crash into tissues, DNA, and as they pull they pull electrons off these things, making more free radicals and making things unstable. Long-term exposure to reactive oxygen species leads to DNA damage and mutation, causing cancer, damages to structures. But it's also a byproduct of a healthy metabolism. We produce oxygen-free radicals, and our body can handle them, provided that we're not compromising ourselves in some way, that our body's systems are working properly and the things we're putting in our body are working properly. Then this is a normal part of a functioning system. Where this becomes unhealthy is when our body is no longer able to deal with these, or there are too many, causing our body to be unable to deal with these. That's the fundamental thing, is our body becoming unable to cope with the amount of reactive oxygen species in it, causing rust, essentially rust in the body, damage to tissues, receptor sites, causing tons of things, causing stress, causing if joint problems, joint pain, depression, anxiety. All these things for the most part can be tied back to inflammation. But again, we'll be covering that more in later videos, but this is a very good baseline understanding. Oxidative stress. It is caused by free radical oxygen species that then crash into cells, crash into things, and strip electrons from it. And let us go on. So, oxidative stress. How does our body deal with oxidative stress? Body deals with oxidative stress by producing antioxidants. I mean, that's linguistically, it makes sense. Oxidative stress, oxidant, antioxidant, antioxidative stress. You can see the etymology right there. So we have the antioxidant system that removes the belligerent drunks, the reactive oxygen species from the club, from your body, and the balance between your body's own antioxidant defense system and the levels of oxidative stress are, I'm at one comment, you'll see me burp. The reason I burp is because I'm taking tyrosine and stuff, and the stuff hits your gut, gas is released. For one, that's a sign of healthy gut acidity, that if you take magnesium, salt, baking soda, some sort of salt, something that when it comes in contact with a low pH solution high in hydrogen ions will produce gas. So to see me burp, that's why. Just like letting you know, so you're not wondering, why is this guy burping? It's like taking tyrosine. The reason I take tyrosine and a few other supplements is I take Adderall for ADHD. So I take those to keep my brain functioning optimally, because any drug, for the most part, causes its effects by causing our body to increase the metabolism of various precursors and things such as magnesium, sodium, B complex vitamins, vitamin C, tyrosine, which is the amino acid precursor to dopamine, which is the primary neurotransmitter increased by Adderall. So that's why I'm burping, if you're curious. But anywho, on with the fun. So the balance between the antioxidant defense system and the reactive oxygen species in our body is basically how our body copes with inflammation and oxidative stress. If we have a very healthy functioning antioxidant defense system, then that's fine. I mean, the belligerent drunks, the reactive oxygen species are removed. The antioxidant molecules released by the antioxidant defense system bond to those, and they just get pissed out of your body. But where things become an issue is when the ADS becomes overwhelmed by reactive oxygen species. There are simply too many reactive oxygen species compounds for the body to produce enough antioxidant compounds to remove them. And this creates reactive oxygen species on their own, create a chain of reaction that leads to more reactive oxygen species. I will actually, yeah, I'll just draw that out quick because, like, I'm a chem nerd. I love chemistry. Draw, paint app. Here we, let me see. Share. So here we have oxygen. We go going over a little bit of organic chemistry here. So here we have carbon. Let's do carbon monoxide. So carbon monoxide minus right there, or plus, actually, that's a plus because it's gonna strip electrons. So carbon monoxide plus. And then we have some other, let's just have like DNA. I'm not going to draw out the DNA molecule, it'd be way too complicated. So it's just DNA. This is carbon monoxide taken from DNA. So carbon monoxide, here's the electrons in DNA. And carbon monoxide has a stronger positive charge than DNA. So that pulls the negative electron off of the DNA, leading to, this all leads to, we have a non-reactive carbon monoxide, which no longer has a positive charge. And now the DNA has a negative charge. DNA, or positive charge, my bad. So DNA now has a positive charge because it has had one of its electrons removed from it. And now this DNA is now a free radical. And this is going to go strip electrons from other things and create more free radicals. And this chain of reaction goes on and on and on until the body, until this free radical runs into a antioxidant. So the antioxidant would be something else that would just donate an electron that would not then cause the carbon monoxide to pull electrons off of DNA and other things that we need. And that's how the chain of reaction goes on, because this will then react to something else and just keeps on going and causes mutations, causes issues. It causes, if two ends of the DNA become charged, when DNA can bond to the other end of the DNA, pull the DNA, it fucks everything up. It's very, very bad. So go back to our PowerPoint. And here we go. So yeah, so that's how that works. That's how the chain of reactions go. And yeah, it's bad. So our body needs to produce these antioxidants to bond to these free radicals and prevent them from creating this chemical chain of reaction that will disrupt all the chemical functionings of our bodies, which is bad. Our bodies are chemical systems. So the balance. So low doses of oxidative stress are good for the body. They stimulate the antioxidant defense system and they trigger adaptation. Too much oxidative stress creates issues because it damages proteins, damages DNA, damages cells, damages tissues, all these things we need to live. And really what we want is we want a balance. We want, like yin and yang, we want our antioxidant defense system to be balanced with our oxidative stress. If those are in balance, that is good. Too little oxidative stress does create problems though. And we'll get into that. So oxidative stress and the ADS. Yeah, for this little cartoon here, because I truly believe that in a symbolic sense, soybean oil is Satan's jizz. We're just gonna leave it at that. I mean, this stuff was uses industrial lubricants in machining, and then some smartass had the bright idea to start putting it in food. And it's caused, see these seed oils, man, like these things are horrible. I'm putting this here, not because I'm a crude individual, but I'm putting this here so you remember. I want you to remember every time you see seed oils that that's Satan's jizz, that Satan jizzed all over that. And that when you eat that, you are importing evil straight into your body, and it is only going to have an evil effect. Only going to have an evil effect. This stuff should never be consumed. Stuff is full of free radical oxygen species. The actual fatty acids themselves are not the sort of fatty acids our body should even be using to construct cell membranes or any of this stuff. So anything your body uses soybean oil for, these seed oils for, will be dysfunctional. Horrible, horrible, triggers lots of autoimmunity, horrible, horrible stuff. Horrible stuff that should never be consumed by anyone ever for any reason. I mean, unless you just want to die. I don't know if you're, no one, but don't want to die. Life is good. Become healthy, become strong, and you'll want to live. So yeah, the delicate balance, oxidative stress, reactive oxygen species are a byproduct of a healthy metabolism, and it keeps the balance. The issue is when we start importing free radical oxygen species by consuming seed oils, rancid oils, processed foods which have seed oils. I mean, you'll notice that pretty much everything that causes inflammation is seed oil related, at least the things that cause the worst inflammation. Other things could be excessive amounts of carbohydrates, like sugar. If you just consume shit tons of sugar all the time, you won't be replenishing your body's reserves, which will lead to a diminished antioxidant defense system, but you'll also be increasing the oxidative stress from metabolism because sugar causes greater oxidative stress than other sources of fuel. And therefore you'll run over. You will have more oxidative stress than your antioxidant defense system can handle, and this will create issues. Here it mentions in the book that fruits and vegetables stimulate the ADS. But it doesn't say is they do that via hormesis. Fruits and vegetables we don't really use those antioxidants because those are plant antioxidants. Maybe we can use them to a little bit. That's an ongoing debate. But to my understanding, fruits and vegetables, 95, 99% of the antioxidants in them are essentially useless to our bodies. But what they do is they have compounds in them that are foreign. And these compounds stimulate the antioxidant defense system because our body's like, oh shit, these things are causing issues. So we're going to produce a bunch of antioxidants to get rid of this. And this is kind of a misunderstanding where people think about fruits and or vegetables really specifically. Let's say vegetables specifically, like, oh, vegetables. Let's say there's a study where consuming, okay, like consuming sulforaphane or something. I don't have any specific studies out on it, so I'm not going to make anything up or misquote something. But basically, you'll see lots of studies where you'll see that they'll prove that consuming fruits and vegetables increases your body's antioxidants, which it does. But it's not because fruits and vegetables have antioxidants that our body is using. It is because fruits and vegetables stimulate our body to release its own antioxidants as a response to a stressor. This process is called hormesis. And again, oxidative stress and inflammation are completely inseparable. So now we're getting into oxidative stress and inflammation, the good, the bad, and the ugly. Boom. So here we have diagrams that I've ripped straight out of Strong Medicine because they're awesome. So short-term inflammation triggers short-term oxidative stress. Short-term oxidative stress also triggers short-term inflammation. This results in injury healing and immune response adaptation and life extension, possibly. The enemy is what prevents this from going away. Because this is fine if it just shows up for a few minutes, few hours, few days. The problem is when this stays around, and how it stays around is this. Oxidative stress triggers inflammation. Inflammation triggers oxidative stress. These two trigger each other. So if you have inflammation, you have oxidative stress, you have oxidative stress, you have inflammation. But our body has the ADS as mechanisms to deal with this and prevent this from becoming an issue. Because, I mean, you look at just this straight away, you're like, Well, the oxidative stress triggers inflammation. Inflammation triggers oxidative stress. If I had any oxidative stress ever, any inflammation ever, they would trigger each other nonstop, back and forth in a system that would never end. It would destroy my body. Not the case because we have the antioxidant defense system. The problem is when we have something that prevents the antioxidant defense system from coming into place, is a constant source of inflammation or oxidative stress. When there's anything that is causing this to remain constant, that is the enemy. So the way to interpret this is we have this natural process going on, but what makes the process unnatural is when there's something that prevents that from stopping. This could be smoking all the time, where you're constantly importing oxygen-free radical species into your body. This could be seed oils and other bad dietary choices where you're constantly, again, importing free radicals into your body. This could be deficiency in nutrition, which is impairing our antioxidant defense system, causing this to continually go on and on forever. This could be the overconsumption of foods that cause stress, such as vegetables. Many people run into thyroid issues and many other issues, but really thyroid issues, specifically by the overconsumption of leafy green vegetables. Many reasons for that, one of which being the high content of oxalates in leafy green vegetables, oxalates being compounds that bond to calcium and render it unusable. But someone knocking on my door, being all friendly and such. But yeah, so we have completely thrown my train of thought. Motherfucker. So yeah, so one of the main reasons people run into thyroid issues, a common reason, is that the overconsumption of leafy green vegetables deprive the body of calcium and also providing stress in the body. I mean, these vegetables are stressful. You'll hear a lot about today, maybe if you're in these circles, but it's very in vogue today to talk about the defense chemicals in plants and how these cause problems. This is the main reason that plants have a hormetic effect. They have these defense chemicals, such as oxalates, for instance, that cause varying degrees of issues for our body. I mean, plants don't want to be eaten, so they produce these chemicals which are meant to poison us. But our bodies, being clever and adaptive, can deal with these poisons. We deal with these poisons by increasing circulation, increasing our antioxidant defense system, and having various changes in our metabolism that are the hormetic result of these compounds. Overconsumption of these compounds over a long period of time will become a source of chronic disease. Seriously, people have developed thyroid issues from overconsumption of juiced green vegetables because they deprive their body of nutrients the body needs via the anti-nutrients in these compounds, and also by increasing inflammation and oxidative stress. Vegetables are inflammatory. Facts. However, in a healthy body, vegetables can be anti-inflammatory because take someone who has a very robust antioxidant defense system and someone who has a very weakened antioxidant defense system. The person with the robust antioxidant defense system consumes vegetables, their antioxidant defense system just goes straight into overdrive and produces tons of antioxidants, more antioxidants than they even needed. And that has an anti-inflammatory effect because it removes oxidative stress, which again, inflammation and oxidative stress are two sides of the same coin. The other hand, someone with a compromised antioxidant defense system will consume leafy green vegetables, for instance, and they just cause inflammation and oxidative stress, but the antioxidant defense system can't deal with this. So now you just have more inflammation. So the same stimulus in two different people produces a different result depending on the context of their body, depending on the health or lack thereof to begin with, and the functionality of various systems. So strong medicine, this book, and the reason this book is so critically important is because strong medicine is the link. It explores the link between, basically, it tries to understand why this system won't shut off in people. And that's the main cause of chronic disease. or one of the main ways of exploring the cause of chronic disease, because you can look at it at many levels of analysis, but ultimately pretty much all chronic disease does come from inflammation and oxidative stress causing damage to the body. Malnutrition also contributes to inflammation and oxidative stress and deprives us of resources, nutrients, things we need to produce proper health, produce all the compounds, organs, organ systems, tissues, etc. we need for proper health. That is one cause of chronic disease. These are related, and we'll be exploring both of them. This book specifically is excellent at understanding the inflammation, oxidative stress, and autoimmune response that contributes to chronic disease. And as it says here, this process causes heart disease, diabetes, cancer, high blood pressure, neurodegenerative diseases, which that also means insomnia, depression, anxiety, potentially ADHD to a degree. It could be a contributing factor in these things, because anything that causes neurodegeneration affects the brain, and that could lead to almost any type of mental illness. I mean, even schizophrenia is related to inflammation and oxidative stress, because these things are causing malfunction in the brain. I mean, I'll explore that more later, but for the meantime, understand that when something causes neurodegeneration, that also means it causes or contributes to every other malfunction of the brain, including all mental illness, at least all biologically rooted mental illness. You could have psychologically rooted mental illness that would not have anything to do with this, obviously, but in biologically rooted mental illnesses, this is definitely one of the underlying factors. And we'll be exploring the other side of mental illness in the Ultramind Solution, which is another book I will be teaching after this. The Ultramind Solution explores the nutritional component. This book explores the inflammation, oxidative stress component, which is autoimmunity. I mean, inflammation and oxidative stress are the byproduct of the immune system. We went over in slide 1 or 2 that the immune system is the major cause of inflammation and oxidative stress in our bodies. Thus, this book is primarily about the malfunctions of the immune system and how that contributes to degeneration and disease. Strong Medicine, again, all about breaking the link between these things and thus preventing chronic disease. So inflammation, oxidative stress, the good, the bad, and the ugly. Most inflammation, oxidative stress, which cause perineal disease, are the result of our body trying to adapt to the outside environment. This includes the food we eat, the quality of our sleep. This is why insomnia is such a pain in the butt to fix, or can be, because it creates a negative feedback loop where you're not sleeping, which creates oxidative stress, inflammatory response, immune response. And that then creates a context for our bodies in which they won't sleep and spirals. And the physical activity in our lives and the stress in our lives. You gotta have nerves of steel to make it in this world. It's not a line from the movie. I just truly believe that. And that is it for today. So tune in for the next chapter of Strong Medicine, where I'll be going over that, and good day.